Hello everybody. In the last class we have started discussing about resistors and we have discussed various points relating to resistors. That is, we have discussed what is meant by resistor, what are the different types of resistors, series and parallel combination of resistors, and some basics of color coding has been discussed in the previous video. And in continuation of the previous video, I would like to discuss some other points which are related to resistors, and that is nothing but resistance and color coding. So the topic of discussion for today is resistance, and also we will discuss some examples relating to color coding. So though we have discussed color coding in the previous session, uh, in today's session we will discuss in detail about color coding, taking few examples of various resistors. Okay, so the learning objectives of today's session are: first we'll try to define what is meant by resistance, and we'll discuss the resistance of different materials, that is how resistance will be reflected in various metals or materials. Next, we'll discuss what are the factors that affect resistance, that is on which factors the value of this resistance will be dependent will be discussed, and later color coding and the calculation of resistance using color coding will be discussed for this video. Okay, now let's start our discussion with the definition of resistance. So resistance, as we all know, resistance is a property that is exhibited by resistors, and resistors are nothing but passive components, bilateral passive components. That is, a resistor is a device or a component which has two terminals and it is a bilateral device. That is, the passage of current can be done either ways. That is, there are no positive and negative terminals indicated for these resistors. And the property that is exhibited by resistors is known as resistance. Okay, so what is meant by resistance? Resistance is a measure of the opposition to the current flow in any electrical circuit. So the opposition to the flow of current is called as resistance. So in general, it is also known as ohmic resistance or electrical resistance. In some cases or in some examples, we may see these terms, that is, resistance will be indicated by these terms called as ohmic resistance or electrical resistance. So any of these terms just implies resistance, that is opposition to the flow of current. In general, resistance is indicated by a letter capital R, and the units of resistance or resistance is measured in ohms, and it is symbolized by Greek letter omega. And there is a meter which can measure resistance, and that meter we call it as ohm meter, OHM-METER, ohm meter. So the unit of resistance is ohm. So ohm meter. Ohm meter is a device which is used to measure the resistance for any particular circuit. In that meters also we have two different types: series type ohm meter and shunt type ohm meter. So this is not the discussion for today, but for basic knowledge I am telling you that the meter that uses or the meter that is used to measure the value of resistance in any circuit is known as ohm meter. And in addition to the ohm meter, there is also another meter or another device which is used to measure high values of resistance, that is known as megger. So keep it in mind, in most of the competitive exams this bit may be asked, that is the device which is used to measure high values of resistance or which is used to measure insulation resistance, and that device is called as megger, MEGGER, megger. Megger is a device which is used for the measurement of high voltages or high values of resistance or insulation resistance. Okay, next we'll see how this volt has been defined. So when a voltage is obtained, voltage is applied across a substance, we know that there will be some electrical current flowing through it. Okay, the applied voltage across the substance is directly proportional to the current through it. This is given by Ohm's law. We know that the voltage that is flowing or the voltage developed across any circuit or any component, it will be proportional to the amount of current that is flowing, and that proportionality constant can be eliminated by using a constant term R. So the constant of proportionality here, what we use is resistance. So what we can write is V is equal to I into R. This is defined using Ohm's law. Okay, hence resistance is defined as the ratio of, so from the Ohm's law we can write resistance as we know that voltage is equal to current into resistance. We can define resistance as voltage by current, that is we can define resistance as the ratio of the applied voltage to the current that is flowing to that substance. So where V is the voltage, I is the current and R is the resistance, then we can write 1 volt by 1 ampere is equal to 1 ohm. Okay, 1 volt by 1 ampere is equal to 1 ohm. So what we can say is that when 1 ampere of current is flowing through the circuit, if that 1 ampere of current, if it is able to generate 1 volt of resistance across that particular substance, and that value we call it as 1 ohm. So the unit of electrical resistance is volt per ampere is called as ohm, and this is named after a German physicist George Simon Ohm. So after his name, the unit of resistance has been given as ohm, OHM, which is indicated by a Greek letter. Okay, so resistance is nothing but the opposition to the flow of current, and it is indicated by letter R. Units are ohms measured with ohm meter or Megger, and resistance is given as volt per ampere and it is indicated by ohm. Here we can also add one more point called as conductivity. 1 by R is equal to conductivity, that is the inverse of resistance is nothing but conductivity. So reverse we can write ohm, reverse can be written as mho. So the unit of conductivity is nothing but mho. So I think I am clear with the definition of resistance. So now we'll see the resistance of different materials. So all the materials do not have the same amount of resistance. Each metal or each material will have different resistance values. Okay, so we'll just try to know how the resistance will be reflected in each of these materials. Okay, so the resistance of different materials, depending upon the resistance value, substances are divided into 3 categories. That is, first one is conductor, second one is semiconductors, third one is insulators. So conductors are nothing but those substances which offer very low resistance to the current through them is known as conductor. That is, those materials which has the ability to pass electricity through them are called as conductors. That is, as they are able to pass current through them, we simply say that they have very low resistance to the current. So there is an inverse relationship between current and resistance. So higher the amount of current, lower the resistance. So for conductors there will be low resistance, that is why more amount of current will be flowing into the conductor. For example, we can take all the metals as conductors, but in that metals also some metals will show higher conductivity, some other materials show lower conductivity. Conductivity is nothing but the amount of current that a metal can carry or any substance can carry is nothing but conductivity. So based upon the amount of free electrons available in that particular material, the conductivity may vary. So for example, if we take silver, silver is generally preferred as a good conductor, but it is not widely used in electrical systems because it is very costly. So though it is a very good conductor, because of its cost it is not generally preferred in the electrical systems. And coming to the conductor, aluminium is also a good conductor, and it is commonly used conductor because it is of low cost and it is widely available. The major 2 points which make aluminium as one of the most commonly used conductor is that easily available and the cost is low. And the third conductor is, for example, if you take copper, copper is also a good conductor and is most commonly used in different electrical and electronic circuits, but it is a better conductor than aluminium, but at the same time it is costlier than aluminium. So when we compare aluminium and copper, both are good conductors, but when we compare aluminium and copper, uh, copper can show better conductivity than aluminium, and at the same time copper is a bit costlier when compared with aluminium. So what I am trying to say is that based upon the cost constraints and as well as the conductivity issue, the selection of the metal for any electrical circuit or electronic circuit will be made. Okay, so altogether what you have to keep it in mind is that the resistance of any metal will vary depending upon its conductivity. So from metal to metal the conductivity will vary, but the base point here is that conductor is a device, a conductor is a substance which can allow electricity through it, and that too it is offering low resistance. When we speak in terms of resistance, for conductors the resistance will be very low. So this point is to be kept in mind. For conductors resistance will be very low. And the second one is semiconductors. So these semiconductors have moderate value of resistance, that is not very high as well as not very low. From the name itself we can conclude that semiconductors sometimes acts as conductors and sometimes acts as insulator. That is, the resistivity property exhibited by conductors varies based on temperature. Okay, so at lower temperatures semiconductors are the materials which act as conductors, whereas for higher temperatures these substances act as conductors. Okay, so based upon the temperature its conductivity varies. Examples for semiconductor can be mentioned as silicon and germanium. Others are also available like carbon and all, but silicon and germanium are the most commonly used semiconductor devices. Almost all the electronic devices or components which are using semiconductor materials are made up of silicon or germanium. And the third type of material is insulators. This is very much contrast to conductors. Conductors will have very low resistance, whereas insulators have very high resistance. That is, they offer extreme resistance to the current, and those substances which offer extreme resistance to current is called as insulators. So these materials are very bad conductor of electricity and are mainly used to prevent leakage of current in the electrical systems. For example, if you take paper, dry wood, mica, porcelain, glass, epoxy, polyester, mineral oil, nitrogen gas, gases and air, these can be considered as insulators because they offer high resistance and do not allow current to flow through them. That is why if you observe any wire, low, the inner side will be made up of metal, which we call it as conductor, and which has very low resistance, so that high current will be flowing, and the outer part of the wire will be made up of any plastic or rubber. Okay, why? Because it acts as insulator, so as that no leakage will be observed, and as well as it avoids shocks. Okay, so these are the three different types of materials that are available with based on resistance. So each metal will have, or each material will show different resistance values according to their internal atomic structure and the availability of the free electrons. So next we'll see what are the factors that affect resistance. So coming to the factors that affecting resistance, all materials have some resistance. Okay, either it may be very low resistance or very high resistance, but definitely all materials will have some resistance. But certain materials resist the flow of current more or less than the other materials do. For example, if we take plastic which have high resistance to electrical current, they are called as electrical insulators. Whereas metals, if we take, they have low resistance to electric current and they are called as electric conductor. Okay, these are the points which we have discussed just now. And in addition to this, if we see this point, that is, a wide wire has less resistance than a narrow wire of the same material. A longer wire has more resistance than a shorter one. Okay, wide wire has less resistance because of than the narrow wire, and at the same time longer wire has more resistance than a shorter wire. So these points should be kept in mind. That is, here the resistance is dependent on the length of the wire. Okay, and as well as resistance is also dependent on the area of the cross section of the wire. That is, resistance is dependent on two factors here. In this statement you can observe that resistance is dependent on the length. Longer the wire, more resistance. That means resistance is directly proportional to length, and as well as wider wire has less resistance. That is, R is inversely proportional to the area. So R is inversely proportional to area of cross section of the wire. So a current must travel further through a longer wire so that there are more chances if it is to collide with any particles of the mat. A cooler wire has less resistance than a warmer wire. So, and also there is a metals called materials called as superconductors. So materials called as superconductors has virtually no resistance when they are cooled to extremely low temperature. Okay, so these are the points which we have to keep it in mind regarding resistance and different materials. So not all the materials will have same resistance, and not all the materials will exhibit same resistance at all the temperatures. So from this we can conclude that resistance will be dependent on factors like temperature, okay, length, and also the area of cross section of the wire. So from this what we can conclude is that factors that affecting resistance can be given as R is equal to rho L by A, where rho is nothing but the resistivity, L is the length of the conductor, and A is the area of cross section of conductor. So on these factors, the resistance of any material will depend. Here another point to be included is temperature. Some metals, if the temperature increases, in some metals if the temperature increases, resistance increases, or if the temperature decreases, resistance decreases. That is, there is a direct relationship between temperature and resistance. These kind of materials are called as positive temperature coefficient. This effect is called as positive temperature coefficient. That is, if the temperatures varies in accordance with the resistance is called as positive temperature coefficient. Whereas in some metals or in some materials, resistance will be inversely relation. That is, if the temperature increases, resistance decreases, or temperature decreases, resistance increases. So this property we call it as negative temperature coefficient. That is, there is an inverse relationship between temperature and resistance. So here the temperature effect on resistance can be of two types. Either it may be positive dependent or negative dependent. Based upon the material, we can, after observing the material, we can conclude whether it comes under the category of positive temperature coefficient, that is PTC, or it may come under the category of NTC, negative temperature coefficient. So any of the case is possible, but the thing is that resistance is dependent on temperature. Okay, so from this we can say that the factors that affect resistance are four. First, it is dependent on temperature, either positively or negatively. Second, it is dependent on the length of the conductor. The more the length, the more the resistance. So as R is directly related to length, if you take more length of the conductor, the more it offers more resistance. Whereas if you take the area of cross section as more, the resistance will be less. And at the same time, it is also dependent on the property called as rho, that is resistivity. Resistivity is nothing but it is a special point, that is specific resistivity for any material. So for each material, specific resistivity is a term that any material possesses. So this has a fixed constant value for each material. For every material there will be one fixed value, and that value will be multiplied with L by A. That gives the actual value of the resistance of that particular material. Okay, so these are the four factors which affect the resistance. Okay, next we'll see. So with this we are clear with the definition of resistance as well as what are the factors that affect resistance have been discussed. Now we'll just see what is meant by color coding, and later we'll discuss some examples relating color coding. So we know that resistors are available in variety of ranges of different resistance, right from fractions of ohms to millions of ohms. So the resistance value, tolerance or wattage ratings are generally printed on the body of the resistors as numbers or letters when the resistor body is big enough to read the print, such as large power resistor. When we see, like in capacitors, if the size or the body of the resistor is big enough to print the value, wattage rating and as well as the tolerance factors, it is easy to print everything on the body of the resistor, very much like capacitors. But when the resistor is very much small, that is 1/4 watt carbon or film type resistors, this specification must be shown in some other manner, as the print would be too small to read. So when the size of the resistors is very small, such that the value cannot be printed. So we should find another way to denote the value of resistor along with the tolerance values. Okay, so in order to overcome these problems, small resistors are used color painted bands to indicate both their resistive value and as well as tolerance, with the physical size of the resistor indicating its wattage rating. So that is, in the previous class also I have discussed that wattage rating this will be dependent on the size of the resistor. The size of the resistor will indicate the wattage rating. Bigger the size, more the wattage. Lower the size, less wattage rating will be there. Okay, so and the other 2 points like tolerance and the value of resistor will be indicated on the resistor with the help of some color bands, and those color bands or those colored painted bands produce a system of identification, and that system of identification is called as resistor's color code. So resistor color code is a way in which we can identify the values of the resistors, that too for small size resistors, with the help of the color painted bands which are painted on the body of the resistor. So the main purpose of color coding of resistor is to identify the value of small size resistors. Okay. So from this diagram you can understand that each resistor will have two terminals, and on the body of the resistor we find four bands. Here two red bands, one black band and one gold color band is there. That is, we observe that there will be four different bands, four colored bands on the body of the resistor. The first red line will is indicating the first digit. The second band indicates the second digit. The third band indicates the multiplying factor, and the fourth band, which is a bit far from the three bands, will indicate the tolerance value. So all these four colors put together will give the value of the resistor and also the tolerance value of the resistor. So just for remembrance, first band indicates the first digit, second band indicates the second digit, third band indicates a multiplier, and the fourth band indicates a tolerance value. Tolerance value is nothing but the slight variation that a resistor can withstand without damage is called as tolerance. That is, if for example if it is 100 ohms, plus or minus 1 or 2 ohms is acceptable. So that acceptable factor or acceptable value is called as tolerance. Okay, so this is color code resistor band representation. And next we see the color code table. So in the color code table, even in the previous discussion, we have seen the color code, that is for black, brown, red. These are the colors. Right from black up to white we use for the first two bands, and the last band, that is the fourth band, generally use gold, silver or with no color. So if it is fourth band is of gold color, we say that the tolerance value is up to 5%. If the fourth band is made up of silver, the tolerance value is up to plus or minus 10%. Whereas if there is an absence of fourth band, the tolerance value can be considered up to plus or minus 15%. So from black to white, 0 to 9 numbers has been indicated by looking at the color of the band that is printed on the resistor. We can identify the value or calculate the value of resistor when we keep all these colors in mind. Okay, so what we do is we just try to check some of the resistors and calculate the value of this resistor. For example, if we take the first one, this one, let me take a pen here. For example, we'll take this one, the first one. So the first one, if we see here, we can observe red, brown, and gold. So red, brown and gold. For the red, what we give is 2, value 2. So you write 2. The first digit is 2. And another red is there. So the value again we write it as 2. For brown, what we write is, from the color code table, brown is given as 1. So what I write is 2, 2, 1. And the tolerance, the third band should be given as multiplier, right? So 22 into 10 power, what I write is, here I'll write. So here I write 2, 2 into third band is brown. So for brown, what we write is 10 power 1. Okay, 10 power 1. And coming to the tolerance value, it is given as gold. That is, we write it as plus or minus 5%. Then what we get is 10 power 1 is 10. So 22 into 10 is equal to 220 plus or minus 5%. So the first resistor value is 220 ohms. So the value of this resistor is 220 plus or minus 5 ohms. Okay. Next we'll clear with this. So next we'll see another one which is more clear. So I'll go with the fifth one, this one. So if we see this, the first we have brown, right? So here we have brown. For the brown is indicated by letter. First one is brown. So I write it as 1. Next, second band is 0 in this particular resistor. So black is indicated by digit 0. So I write 0. Next is third band, that is multiplier. Multiplier is here orange. For orange, we give it as 3. So write 10 power 3. And the last band for this resistor is gold. So gold is tolerance, that is plus or minus 5%. So what we can write is 10 into 10 power 3000, that is 10 kilo ohms plus or minus 5%. So the value of the fifth resistor is nothing but 10 kilo ohms resistor. So brown, black, orange, gold will give us 10 kilo ohms plus or minus 5% of resistance. Okay, next we'll see the last but one, that is this one. We'll see this one. We'll check this one. So if we observe, this one is placed in reverse fashion, I guess. So we'll start from this side. So every time gold will be the fourth band. So here we see gold in the first place. That means it is in the reverse direction. So we'll count from this side. So here it is given as first band is yellow. Next one is violet. Then we see orange. And finally we see gold. So let's calculate based on the values. For yellow, we write it as 4. And for violet, that is value number 7. And the third digit or third band is orange. So for orange, we write it as, the value is 3. So we write it as 10 power 3. And it is gold. So plus or minus 5%. So what I can write for the last but one resistor is 47 into 10 power 3. That is 47 kilo ohms plus or minus 5% is the value of this particular resistance. Okay. So this is how we calculate the values of resistances using color codes either for carbon or film type resistors, which are very small in size, as their size is unable to print the value of the resistance as well as tolerance on it. So we indicate the value of the resistance with the help of color code. Okay, again we'll solve another problem here. So just we'll check this one, sixth one. So from the sixth one, we see it as first is red and the second band is red, third band is orange and fourth band is gold. For red we write it as first band is 2, for gold we write 2, and for orange it is 10 power 3, and for gold it is plus or minus 5%. So altogether what we can write is the value of this particular resistor is now 22 kilo ohms. 22 kilo ohms plus or minus 5% is the value of the resistance for this particular resistor. Okay, we'll solve this one also. So 3 reds are there. So for red we give as 2, again 2 into 10 power 2 plus or minus 5%. Then we can write it as 22 into 100. So we can write it as 2.2 kilo ohms. 2.2 kilo ohms plus or minus 5% is the value of this particular resistance. So just by looking at the values of colors, just by looking at the colors prescribed on the resistors, we are able to calculate the value of resistor. So this is the case only with the small size resistors. When we move on with the big size resistors, everything will be printed numerically, like its tolerance value, resistance value, and also wattage ratings and all will be clearly written on the resistors. So this is only the case with the small size resistors. Okay, so I guess you people are clear with the concept of color coding and the calculation of color coding. So I guess we can stop the class for today. So in the next coming classes we will be discussing other points from this same chapter. So as of now, just to brush up what are the things that we have discussed. Just we'll see that in this today's session we have discussed points like what is meant by resistance, and the resistance of different materials has been discussed, and the factors affecting the resistance, color coding, and resistance calculation using various resistors. Color coding has been learned in this session. So with this I'll conclude for today, and let's meet in the next video. Thank you.